All right, everybody, this is going to be the video for Geometry Unit 8, Lesson 3. Should be a pretty short one. There's some stuff in Lesson 3 that you don't really need to worry about. So we're going to focus on the one thing you do, which is Euler's formula. So Euler's formula is a test to determine whether or not something is a polyhedron. And so if you remember, a polyhedron is going to be a shape that is made of straight line segments. Now earlier I didn't say that there were certain kinds of shapes made of line segments that weren't polyhedron, but there are. So I didn't give you the full story when we did lesson 1, but now I'm kind of giving you the details, and that is that they actually have to fit this pattern that Euler, Leonhard Euler, who was a mathematician, and I think he was from, he was Swiss, and he lived in the 1700s, and he determined that polyhedrons have to meet this requirement. And these letters stand for the following. V stands for vertices. You should remember that word. It's the plural of vertex. So that's the number of vertices in a figure. And if you remember, it's the points. It's where all the line segments meet. E stands for edges. Sorry about my messy writing. Edges is going to be the lines that make up the figure, the edges. Okay, and then lastly we have faces. So I'm actually going to grab something for us to use for this example. So give me just a second. All right. So I'm going to use this box as my example. It's maybe not the best option, but that's okay. That's what I have. So looking at this, okay, and we want to count the number of vertices, edges, and faces that there are in this box. So we'll start with, I think the easiest actually is faces. I actually usually start there because I can just go, okay, I have the lid, I have the base, that's 1, 2, and then I have the 4 sides around. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 faces. So there are 6 faces on this box. And so then I'm going to go for edges. It's a little hard to count, but I'll just do, let's go around the top. 1, 2, 3, 4. Those are all edges. 5, 6, 7, 8. And then on the bottom, 9, 10, 11, 12. So there are 12 edges. Sometimes it's hard. You just have to try your best to keep track of what you count and what you haven't. And then my vertices are going to be all the corners, basically, because that's where the edges meet up. So 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 of these vertices. So again, to recap, vertices are the corners, edges are the lines, faces are the flat surfaces. So now we have our three answers. And so I'm going to use the formula to see if this box is a polyhedron. And so we go in and we do V, which is 8, minus E, which is 12, plus 6. So we use order of operations. We just go left to right. There's really nothing complicated about that. 8 minus 12 plus 6. And I do get 2 when I do that. So that means that this box is a polyhedron, and that's how you use Euler's formula. So all you're going to be doing in the unit is counting the vertices, edges, and faces, and then plugging them in to this formula and finding out if something is or is not a polyhedron.